In this video, we're going to round out our conversation about functions and loops by doing a little bit of experimentation with the speaker. And what we're going to try to do with this speaker is like anthropomorphize a robot. Like anthropomorphize the various sounds that a robot could make to kind of express emotion, right? So you could think about something like R2-D2. Like it's just a series of different like beeps and tones and frequencies. But the way in which it's done and like the different inflections that you get can kind of convey some different emotions. And so that's what we're going to try to do here. So as a starting point here, I have set up my Arduino here to have a single piezoelectric buzzer here where the minus leg is connected to ground and the plus leg here is connected to pin 12. And then if I go back over to here, what I've done is I've defined the speaker as being connected to pin 12, set up my serial port, set up the pin mode for my pin 12 to be an output. And then I've also pasted in all of these different frequencies and defined them as macros associated with a particular note. So what this is like the first A that you see on a keyboard is 27 hertz. The next one would be 55 hertz and so on. So it just does this mapping so we don't have to look up or memorize all the different frequencies. So we can say go from like this C note to this C note and it'll know what frequencies we're talking about. So I included that right up here at the very top. And so now what we're going to do is we're going to define our own function. Now I've experimented a lot with these different sounds here to try and figure out, how to kind of make it sound like happy or sad or these various different emotions. And so I'm going to give you a lot of the values and feel free to tweak them because it kind of came from a lot of like trial and error, which I didn't want to belabor a whole big long video of all the trial and errors that I've done. But I'm going to kind of show you this process and then you can take it and adapt it to your specific scenario. But what I've found is really helpful is creating some function that will allow us to run from one frequency to another frequency at like various different speeds and various different steps. So you can think about it like running a scale kind of really fast to do like some upward inflection or running it down to do some downward inflection. And so you'll kind of get the hang of this as we start to implement it here and hear these various differences. But what's going to be the key is this function that we're going to write. And so what we're going to do is just write some function. It's not going to return anything, so we'll define it as void. But what it will do is it will have the side effect of playing a sound through the speaker. And I'm just going to call it bend notes because that's what we're doing. We're bending between two different notes. You can think about bending a guitar string or going from or like using a pitch bender on like a synthesizer or something like that. And so there's 5 different pieces that we're going to need to give it, 5 inputs that we'll need to give it in order for it to do its job. So the first 2 are going to be pretty straightforward. This is going to be like the start frequency and the end frequency. This is where we want it to start and then where we want it to end. So it's going to go from this first value up to the second value, or if this first value is higher, it's going to go from here down to here. All right, and then the next one is going to be the weirdest one. So this is some float value, meaning some decimal value that is the proportion of which we want to increase or decrease it by. And so like for a proportion, we would pass in something like 1.05, meaning that what we want to do is we want this value to increase by 5% or like decrease by 5% each time, going from the start to the end frequency. And so we'll see how to do that here in a second. And then the last 2 pieces are going to be durations. So the first is going to be the note duration, or how long we want each note to play aloud. And then the second one is going to be like the silence duration, which is like how much space we want between each of the different notes here. And so that's going to be it for our input arguments here that we're defining as a part of this. And so now what we're going to do is we're going to create this for loop here. And what we're going to do is we're going to define it as a float. Our like control variable here is a float because we're going to continue to multiply it times this proportion and change it. So it's going to be a decimal value. All right, and so what I'm going to do here is define it as the variable frequency, and I'm going to set it equal to the start frequency to begin with. And we're going to continue to go until it gets beyond the end frequency. So I'll say frequency less than end frequency. Yeah, that's what I call it. To have it continue until it's no longer less than the end frequency. And then what we need to do is define how we are going to update this control variable each time the loop is done executing. So what that's going to be is going to be frequency times equals proportion, which is the same as saying frequency equals frequency times the proportion, which is basically just going to, like, if I pass in a value of 1.05 and my frequency is 100, if I multiply it times that, the result is going to be 105. So that's going to be our next frequency. And then we multiply 105 by 1.05 again, and we keep increasing by that proportion over and over and over again. Okay? And so now what we need to do is define the guts of what's going to happen inside of here. So basically what we're going to do is we're going to play a sound for a specified amount of time and then delay for some amount of silence here. And so what we'll do is we'll call tone, and it tells me here what it expects. First, it expects the pin number where the speaker is. So I created this pound define macro up here where I said that it is 12, so I can just call that SPKR for speaker. And then what I need to do is pass it a frequency. And so that's just going to be the value here that we've computed as frequency. And then the last value is the duration, which is just going to be the note duration. And I know that this is kind of covering up what we had up there, but those are our variables, right? So frequency is that, note duration is that. So that's going to play this note on this speaker for this duration. And then the last piece we have to say is how long we want it to stay silent for. And so what we'll do is we'll just delay for the silence duration, like that. All right, and that's the end. But this would only work for some starting frequency up to some end frequency if the end frequency was higher than the start frequency. It wouldn't work the other way around. So before we get into how we would change it to make it work for that, let's try and make sure that it works. All right, so what I'm going to do is I'm going to call bend notes, and I'm going to pass it some values here, right? So I could just say, let's run from note C4 to note, I don't know, G5 maybe. And let's do that 1.05 that I mentioned. And I don't know, let's just play around with some values here. So we'll say something like 20 and 10. Now let's listen to what this sounds like here. And it would just kind of keep playing over and over and over again. So I'm going to add in like a decent delay here so that we don't hear the sound like infinitely and it drives us crazy. So I'm going to upload this and we'll see what happens. So there we go. We kind of hear that it goes up in frequency and then stops. And so we could play around with these different values to see how that impacts it, right? So I could change this to 1.01 to have it increase slower. So it should take a bit longer. So let's upload this and see how that modifies it. Yep, so it goes to those same frequencies, but over a longer period of time because it's changing. You know, the differences between each of the different notes that it's playing is smaller when I'm doing a smaller proportion than here where I'm doing like a larger proportion. So if I do 1.1, that should be like really quick. And you can also play around with the durations to see how that changes things as well. But now it's like really short, and change it back to here. And just see all sorts of different things. So what I'm going to do is I'm going to comment out this line and just upload a program that doesn't play any sound so that we can kind of continue talking about what we need to do to make this work and not be interrupted by a bunch of background sounds. All right, so we said that this works for when the starting frequency is less than the end frequency. What we would need to do is go in the opposite direction if the end frequency is less than the start frequency. And so what we're going to do is we're going to add a condition here to check that case. We're going to say if the start frequency is less than, or we can just say less than or equal to the end frequency, we will do this for loop here. All right, so I'm going to indent this and just get my formatting good. And then what we can do is otherwise we can do a different for loop. It's going to be pretty similar, But what we'll do is we'll just change a couple things here. All right. And so we're saying that this is when the start frequency is less than or equal to end frequency. This is when it needs to go from a larger value to a smaller value. So we're still going to start it at this frequency, but what we need to do is we need to stop it when the frequency is no longer greater than the end frequency. So this is the condition under which we want the loop to continue to execute. And then we need to change this right here to say, how do we want it to change by? And just the easiest thing we can do is change this here to a division, so that we're saying that the next frequency is going to be equal to the current frequency divided by that proportion that is provided to us. All right, and so that should do the trick here. So I'm going to have it go from the low frequency to the high frequency, and then wait for 100 milliseconds, and then have it go in the other direction. So I'll change this to G5, and I will change this to C4. All right, and let's upload it and see what we see. I guess we don't really see anything, we just hear it, but there we go. So it goes up, down. So you can already hear a little bit of like how we are like somewhat emoting just by bending these different notes here. So we could talk about how to make like a happy sound or a sad sound and things like that. So again, what I'm going to do is I'm just going to upload a program that doesn't play any notes so that it's not constantly interrupting us. And we can talk about how we can make these various different sounds here. Okay, so let's go like this. So what I'll do here is I'll say, I don't know why my enter key doesn't work sometimes, but there we go. So let's do a happy sound. So I'm just going to label this as happy. I'm going to get rid of that window so we can see what we're doing here. And so I think for like a happy, what we'll want to do is go pretty high up in pitch and then come back down. And so that's what I did here. These are, again, just some values that I found that worked well. So I went from F6 to D7, and my proportion was 1.05, and I said like 40 and 15. Okay, so I'm going from a fairly high pitched note to an even higher pitched note, and then a little bit of a break, and then I change it. So I'm actually just going to paste it from my other thing here that's on the other side, just so that it's easier, so I can walk through and explain it. So I went from F6 to D7, a proportion of 5 with a note duration of 40 and a silence duration of 15. And then I went again from D7 back down to F6. So I go up and then down. And then this one, the notes are a little bit longer, but the silence duration is the same. So that's what I did for like a happy-ish sound. All right, and then let's see, for like a cutesy sound, I played around with it for a while, and I went ahead and just did this here. So I said, all right, start again at that same note, go up to this note, but go up a little bit quicker just because the notes are lasting a little less long. And then the next sound is still going up. It's going from B6 now to an even higher note, E7. And so let's hear how both of these sound. And what I'll do is I'll add like a little bit of a delay between each of them so you can kind of tell the difference here, right? So there's that one and there's that one. So I can upload this and we will start to hear what's going on, and I can like print little names here for what's happening. So there's our happy sound, and there's the like little cutesy sound. There's a happy sound and the cutesy sound. Oh, now I'm messing everything up. There we go. So yeah, it can start to get a little annoying after a while, but what you can imagine is like adding this code to some sort of robot, and like when certain things happen, you play a sound that corresponds to it. All right, so to kind of round out our example, what we're going to do here is we'll add like a sad sound to kind of do a more full spectrum of emotions here. All right, and so what I did for this one, what I found that worked well, is you go from a high note to a low note, but you go slowly and kind of have a good space of silence in between there. And so this is what I found works. I go from A5, which is actually higher than E5. If we look up here, yeah, we have A5 here, which is a higher frequency than E5, which is here. So what I did is I go from this higher frequency to this lower frequency with a smaller proportion of 1.02. I do like a similar note duration, but I do a much longer silence duration. And I found that this works very well for doing these sad sounds. So I'm gonna, again, add that delay, and we can add like another serial.print ln and do sad. And let's upload this and kind of hear how it sounds, and I'll pull up the serial monitor so we can see what's going on. Let me clear it out. So there's the happy, the cutesy, and then the sad. So there you have it. This is just kind of ways that you can play around with these various different sounds and kind of anthropomorphize your robot. And so with this function that we built, there are all sorts of different things that you can do. Those are just a few different examples, but you can imagine doing like a little surprised, or kind of like a sleepy tone, or like a uh-oh sound. Kind of all sorts of different things could be done just playing around with this one function here. So I invite you to play around with it and see what you can do.